Hello everyone, welcome back to our course Python for Data Science. In this lecture we will continue our discussion on Pandas data frame. From last two lectures we have been exploring about Pandas data frame. For a quick recap, we have seen the types of data and two broad categories, first being numeric, and second being object, which is character type. We have also discussed about best use cases for both object and character data types. And also understood the reasoning behind choosing between categorical, or object data types for efficient manipulation, and memory utilization of character type data. We verified the data type of all the variables, getting the count of unique data types. We have seen the way to select data based on their types. We have seen the summary of data frame like variables and their data types. We have looked how many null values each column has. And along with that, we verified the memory usage by each column. We have also seen that few of columns are not been read correctly, so we have gone back and verified the unique elements of each column to understand why data being not read correctly. We observed in the previous lecture and have seen that there are some special characters like question mark are present in some cells. And by default, Pandas will not consider them as blank values. That is the reason from this lecture we will import the data considering all kind of special character as blank value. Let us compare the summary of difference between the importing the data with or without considering special character. Next, we will be converting the columns to appropriate data type, as we have seen that some of the column data types are not read properly due to unexpected values. We will look into the category data type in detail, and understand which type of data type is appropriate for particular variable. Next, we will be handling the inconsistent data in the door column, since it has few entries such as string number like 5 in single or double quotes. We will also look into the way to handle missing values in the door column. So, this time while importing data, we have taken care of missing values and represented them as nan value. We will use the syntax pd.read_csv of cars data. We have also given argument index_call is equal to 0, to make first column as index column and. For example, in our cars data, we have also handled the special character case like double and 4 question marks and converted them to nan values. Just to recall, by default, Python considers blank values as nan value. Since now we have imported the data considering all forms of missing values, let us now compare the concise summary of data frame with the data imported without handling missing values. So, in the new data frame we have replaced the question marks to nan values. If we see the difference after replacing question marks, the count of non-null value of the kilometer column decreased from 1436 to 1421. So, in the original data, KM column did not have any missing value, but after replacing question marks with nan value, the count of non-null value decreased from 1436 to 1421. You can also see the similar observation for the horsepower column, where the count on non-null value decreased from 1436 to 1430. So to summarize, these steps are very crucial while performing any data analysis, and you should make sure that the all types of missing values and special characters are treated as the default nan value. Moving to next, now we will handle the problem of wrong data type. In our last lecture, we have seen that some of the variables are been not read as correct data type, and we have also identified the reason behind it. For such things, we can use astype function to convert data type from one to another. So, you have to specify the data type to which you want to convert to and apply to specific variable in your data frame. We will be converting the metallic color and automatic variable to object data type from float64 and int64 respectively. So, here I am accessing the metallic variable from cars data frame and using astype function to convert the data type from float64 to object. And also, we want to reflect the changes back to original variable. We have equated that to metallic variable of the cars data. And similarly, we have done the same for the automatic variable and equating so that the changes are reflected to original data frame. Now we have converted the metallic and automatic column to object data type, but we also have two types of character-based data like object and category. So, for example, we will convert the metallic variable or any other data type to category and we'll see what is the impact of changing the data type of the variable. Let us first check the total bytes consumed by a variable. The nbytes command is used to verify the same. In our case, we will look into the bytes consumed by fuel type column while being data type as object. So here we have accessed our data frame's fuel type variable and used .nbytes to get the total amount of bytes used by the column fuel type, and we can see that it's consuming 11,488 bytes. Now we will change the fuel type variable from object to category data type, using the same astype function. So, we can see that when the fuel type variable was of object data type it was consuming 11,488 bytes, and when we changed the data type to category the same fuel type variable is using 1460 bytes. It is very much clear that the category variable consumes considerably a smaller number of bytes as compared to object type variable. We can save a lot of memory using these best practices when dealing with large dataset. For example, it's always better to use categorical object type when the values are in string format. Since we are dealing with small dataset, we will not be looking each and every variable. I have just for illustration purpose shown the example and best practice for efficient memory utilization. So if we check the concise summary of our data frame, we can see that now metallic and automatic variable are of object data type while the fuel type variable is now of category data type. Next, we will move on to cleaning the door column values. In the previous lecture we have seen that the door columns have some values as string numbers and some values as numeric numbers. This can be example of mistyped entries. So, if we print the unique values of the doors column, we can see that we have 3, 4, and 5 numbers as string value. To have a consistent data either we need to change all the numbers as string value or we change all the string numbers to numerical numbers. We will use the .replace syntax to replace all the string numbers to numeric. So we have value use the dataframe.replace syntax and inside the function we given the first value which needs to be replaced and second item as the value which will be used to replace. Using this command, I am replacing string value 3 to numeric value 3. And the argument is in place equals true. This parameter in pandas is used to modify the data frame directly without creating a new copy. For our case specifically, all instances of string 3 in the doors column are replaced with numeric 3 in the data frame df1. And the modified doors column is assigned back to df1 doors column, effectively updating the doors column in df1. We will do the same for other string values such as 4 and 5. Alternatively we can use np.where function to find and replace the values. Now since we have converted all doors column values to numeric, so next we will change the data type of doors column to integer. And to explain why we would want to convert the data type to integer, as when you add or replace values in a column, Python treats these modified values as a new set of categories. For example, if you add 3, 4, and 5 to the existing level, Python will consider these values as new categories. So, by converting to int 64, the original levels are preserved, and any replaced values do not create new categories but are reflected back as numerical values in the original levels. So, in our case, the conversion ensures that the numerical values such as 2, 3, 4, and 5 are represented as integers rather than strings or categorical variables. Now we will check whether there is any missing value is present in data frame or not. For doing so, we will use the command dataframe.isNull.sum. The isNull function gives the output of Boolean value true or false, so when we apply this function to our data frame, basically it will represent the missing values in cells as true, and in the case, the cell do not have missing value, it will represent it as false. And we have also used the .sum to add up the missing values in each column. This will give us the count of missing value of each column. As we can see that, the age and fuel type column has 100 missing values, the kilometer column has 15 missing values. And similarly, the HP in kilometer variable has 6 and 150 missing values respectively. Now we know that we have missing values in each column and to highlight the missing values are not consistent across each column. To handle such situation, we need to strategize our logic, which is built on case by case depending on the data frame we are analyzing and the problem which we want to solve. In upcoming lectures, we will build the logic to handle all these missing values for each variable specifically. Let us now summarize our today's lecture. So we started with importing our data with indexing and handling special characters. Then we converted all the missing values as NaN value. And after that we have changed the data type of few of the columns as per expected data type. Next, we have seen the impact of memory utilization using the object or category data type. We have also optimized the doors column by converting it to integer type and changing the string numeric value to integer. We also got the idea of count of missing value each column has. In next video, we will discuss about control structures and functions and building up the logic to handle missing data. We hope that you have found this course informative. Please hit the like button and subscribe to our channel for more informative Python for data science course. Your support means a lot and motivates us to create more educational resources for you. Stay tuned for the next lecture, where we'll continue our journey through Python's data science course. Thank you for watching and